All right. So if you like to put a title on your notes, then that's fine. The title today will be Dividing Polynomials. Today we will be dividing polynomials. And just a disclaimer while you're getting ready to start. This skill is needed to do tomorrow's skill, is needed to do the next skill. Okay, so we always build in math, but like it's for real this time. Like you will not get anywhere tomorrow. We cannot do what we're doing today. So it's critical that we're on top of this today. Okay. All right. So the first thing I want to do is I want to take you all the way back to elementary school, or apparently if you're in Mr. Jones' chemistry class, he makes you do long division by hand, which is excellent. So let's go back to elementary school and do some long division. So let's say I've got 3, 4, 5, 6, and let's just kind of remember for a moment how we do long division by hand. So the first thing I'm going to do is I'm going to be like, okay, how many times will 2 go into 3? Well, 1 time. Then 1 times 2 is 2. And then I subtract that. And I get 1. And I bring down the 4. Okay? So I divided, I multiplied, I subtracted, and then I brought a number down. And then I go back and I begin the process again. How many times will 2 go into 14? Well, that's 7. 7 times 2 is 14. Subtract, and I get 0. And I'm going to bring down this number. Now I have 5. How many times will 2 go into 5? Well, 2. 2 times 2 is 4. Subtract, I get 1. And then finally I'm going to bring this down here. So 2 goes into 16 8 times exactly. And I'm done now. Yeah? Ringing a bell? Somewhat? All right. So we're going to do this with big, long equations today. So that's why I wanted to kind of preface with just the numbers, just to kind of remind you of the process. So let's start with example number 1. So let's say 2x squared plus 12x plus 11 divided by x plus 5. Because fractions are just division, right? It's just another way to write a division problem. And so to write that like long division, I'm gonna rewrite this thing like this. So I'm gonna say, okay, so I'm just gonna rewrite it as a division problem. Okay. So 2x squared plus 12x plus 11 divided by x plus 5. That's the problem we're doing. I'm going to use some color today. So I want you to watch what I do. You're welcome to write while I do it, but I'm going to walk through it and then I'm going to go back and explain it again a second time. Okay? So don't fret if you're writing more than listening. First thing I'm going to do is I'm going to take x and I'm going to determine how many times this x goes into this. So the first thing goes into the first thing. And I'm going to kind of do my scratch work out to the side. So 2x squared divided by x is just 2x. And so I'm going to put that right here so that I have both x's are lined up. Because organized work is important with this. So now that I have divided, I will multiply 2x by this whole thing. So 2x times x is 2x squared. 2x times 5 is 10x squared. Now I'm going to subtract. And I'm going to subtract the whole thing. Recall from yesterday that when you subtract an expression, you need those parentheses so that you can remember to distribute the negative. So, I just distribute my negative here, and now I will proceed to do those calculations. Okay, so 2x squared minus 2x squared is just nothing. 12x minus 10x is 2x. And now I'm going to bring down the 11. just like we did before. So in this next step, I'm ready to divide again. So I'm going to again just look at this first thing and divide it into this first thing. So here's my scratch work to the side. 2x divided by x is simply 2. So this is a constant, so it's going to go over here on top of the other constant. And now I'm going to multiply 2 by all of this. So 2 times x is 2x. And 2 times 5 is 10. And now I'm going to subtract again. Distribute my negative. 2x minus 2x is nothing. 11 minus 10 is 1. Now, at this point, we would be ready to divide again. But let's notice a couple different things. X will not go into 1. Also, the top is all full. Right? There's nowhere else to write anything. So this is the remainder. This is the remainder. And we write this in a specific way with polynomials. We write it as a fraction of the original divisor. And what I mean by that is I say, okay, this is a positive 1, so this will actually be plus 1 divided by x plus 5. So all that being said, let me go through it again, just in case we missed a small detail, which is possible because it's a lot of work. So first thing I did is I just took my division problem and rewrote it into a long division format. Okay. The next thing I did is I looked here and I said, okay, I'm going to look at the first thing and the first thing only. How many times does x go into 2x squared? Well, 2x squared divided by x is 2x. I put the 2x here because it's on top of the other just regular old x, the other linear part. So that's the divided. Now we multiply. 2x times all of this. So 2x times x, 2x squared. 2x times 5, 10x. Now I subtract all those things. Okay, so I subtracted, distributed my negatives so the subtraction is correct. And then that's nothing. Then I get this number, I'll bring the next number down. So I divide, multiply, subtract, and bring down. Divide, multiply, subtract, bring down. So at this point now I'm ready to divide again. But I divide here. The first thing by the first thing again. So 2x divided by x is simply 2, it goes here. Division's done with. Now we multiply. 2 times all of this. 2 times x gives me 2x. 2 times 5 gives me 10. Subtract, distribute negatives, do the calculation, and we end up with a 1. I know that I'm done now because if I tried to go back and divide again, it doesn't go at all. Right, it's just done. And there's no more room for the division. So this is a remainder, and to write the remainder as part of the polynomial, we do so as a fraction. So it's just plus, that's positive 1 divided by this. 1 out of the s plus 5. Was there that? Yeah. So again, organizing, keeping track of your steps. The number one problem with long division with polynomials is people forget to distribute that negative. It's sign errors all day long. So just be aware of that when you start your work later. So let's do example number 2. This one will be written a little differently. 12x cubed. Whoa, there we go. Minus 2x squared. Minus 20x. Plus 17. Divided by. This is just another way to write divided by. So there's that. That looks stupid. Hold on. Somebody's going to be like, what is that on the end? It's a parenthesis. All right, so again, it's just a different way of presenting the problem, but it's still division. So immediately we want to rewrite it as a long division type thing, right? So like we want this bar here. I want this to look real nice and neat. I leave a lot of space because that way things don't get jumbly at the end. Uh-oh. Okay, now we're ready to start. So just like before, I'm going to look at the first thing and the first thing. And let's see, 12x to the third divided by x is actually just going to leave you 12x squared, yeah? So I'm going to put that here above the other squared number. So I've divided. Now I will multiply. So 12x squared times x is 12x to the third. 12x squared times negative 1 is minus 12x squared. And now I'm ready to subtract. And before I do so, I want to distribute the negative. So this term will go away, that's just 0. And then when I do this calculation, it'll just be 10x squared. And then I bring this next one down. Divide, multiply, and subtract. Now bring it on down and then bring it on back to sing you a song. All right, I'm ready to divide again. So I'm going to again look at the first part of this and divide it into the first part of this. And so here's my scratch work to the side. That'll just be 10x. Well, that works. So that's the next part here. So that's the division. Now we will multiply. 10x times x is 10x squared. 10x times negative 1 is minus 10x. Now I'm ready to subtract. And distribute the negative. That drops out, so that lets me know I'm on the right track. This first thing should always go away. Negative 10x, and then we're going to bring this next thing down. You don't have to do the arrows, it just helps me keep up with where I'm at, what I'm doing, and what I've already done. So we brought it down, and once we bring it down, the next step is to divide again. We're going to go again and say, okay, I'm going to divide the first thing into the first thing. And so my scratch work is here, negative 10x divided by x. It's going to be just negative 10. So here will be negative or minus 10. We carry that sign with us, okay? It doesn't just go away. And now we'll multiply again because the division part is over. So negative 10 times x, negative 10x. Negative 10 times negative 1 is positive 10. Now we're again ready to subtract. Distribute the negative. That drops out. This is a positive 7. Does x go into 7? No, so this is my remainder. And so we'll write the remainder as a fraction. 7 over the original divisor. Let me highlight it because it's kind of jumbled. This is my answer. All right? So it's an exercise in organization and keeping track of a lot of steps and a lot of stuff going on at once. All right, example number 3. Woohoo, these are long.
Wait, can you go?
I will. Sure.
Yeah, how does the plus 7
Got it? Question.
Yeah, fine. The plus 10.
Yeah,
I thought it was going to be minus 10.
It's plus negative.
It's negative 10.
Yeah, it starts off as negative 10.
Oh, yeah.
So it's add negative 0.
Wait, isn't that under because you got it?
Say again?
Everybody had a multiple of them.
And then make it.
Wait, how do you get negative 2?
Negative 10 because I divided x into negative 10x. So negative 10x divided by x is just negative 10, so negative 10.
Because I put it in negative 10.
Ah, yeah, the x would cancel here. So it's just a negative 10. And we would expect that. We would always expect, if we've already written that 10x term or an x term, the next one will be x to 0. So it's going to come out in standard form.
So there's not going to be like
You're never going to have, no like terms. If you have like terms, because the way we set up the problem, we're going to set it up in standard form so our answer comes out in standard form, okay? And that's actually what we address in the next example. So hold on, let me get it written down and then kind of explain a little more, okay? Oh, why is it doing that? Let's try that again. There we go. Okay, we're gonna probably be in notes for the next like 20 minutes if you wanna go.
I can.
You sure?
Yeah.
Okay. Right, so let me see, example number 3. So let's just go ahead and let me write the problem here. So example number 3 is x to the 4th plus 16 minus 17x minus 17x squared minus x cubed divided by, push this up a bit, negative 5 plus x. Negative 5 plus x.
Is that number getting bigger? Like as we go?
What is it?
Like right there, it's always been 2 terms. Is it gonna be more?
Yes. Yes, there will be more. All right, so on this one, so let's look at the first two. Notice that the first two are in standard form. So notice when I write these, they're nice and, squared, power 1, power 0 of x. There's nothing missing. All right, it's in standard form. And the next one's in standard form as well. So I have the x first, and then the constant term, and I have cubed, squared, linear, constant. No breaks. This is not like that. All right, so we have to make it like that first. So we're gonna do a couple things. So when I'm rewriting everything, I'm gonna write it in standard form. So that's what goes on the outside. And then I'm gonna write this in standard form. So I'll have x to the 4th minus x to the 3rd minus 17x squared minus 17x plus 16. All in a row. No breaks, no skips, no nothing like that, okay? Now we can go ahead and do what we did before, okay? So I'm going to start by dividing the first into the first. That'll be x to the 4th divided by x. That's just x to the 3rd, so I'm going to set that right here. Now I'll multiply. X cubed times x is just x to the 4th. And that's minus 5x to the 3rd, and now I will subtract. Distribute. So that drops out, which is what I would expect. This would be 4, no, 5. Oh, that's cool. What's it doing? Look at it. Oh, it just crashed. That's awesome. All right. Well, stand by for just a minute. Okay, sweet. Thank you. Oh, my good Lord. Don't do that to me. All right, so it did not pick up my sign changes. So there we go. Again, I knew that immediately because this wasn't dropping out. It wasn't turning into 0. So this would be 5 minus 1, so that'd be 4x to the 3rd, and then I'm going to bring this guy down, minus 17x squared. Now I'm ready to divide again. Let me do another color. Take this first thing and divide it into this first thing. 4x to the 3rd divided by x will just give me 4x squared. So that goes here. I divide it. Now I'm going to multiply. Let me get rid of this because I keep thinking it's a negative. So 4x squared times x, that'll be 4x to the 3rd power. 4x squared times negative 5 will be minus 20x squared. Let's subtract. That goes away. Good deal. That's 3x squared. Bring down another negative 17. And now we divide again. Get another color. Do this. And we're going to divide it into this. So we'll have 3x squared divided by x, and that'll just give me 3x. Which would be exactly what I would expect, because I expect a linear term to come here. So then we'll have 3x squared. 3x times negative 5 is minus 15x. Let me get some more space to move this up. Now let's subtract. Distribute the negative. And I'm left with negative 2x. And I think there's one more thing to bring down. Yep. See, I know I haven't brought it down because I don't have an arrow. That's why I like using that arrow business. So now I'm ready to divide yet again. So my last bit of work will be negative 2x divided by x, and that's just negative 2, so that'll be minus 2. And now I'm going to just multiply again. So negative 2 times x, what is it? Oh, negative 2 times negative 5 is positive 10. Subtract. Sign changes. That's a 6. Is there any room to divide again? Nah. So that's my remainder. Plus 6. Whew. So hideous. So ugly. There we go. All right, let's do, I have 2 more examples for long division, because they're both kind of different in some way. So the thing we just looked at was that it's super, super, super important to have it in standard form. What this next example is going to illustrate for us is that it's really, really important to not have holes in the polynomial, no skips in the powers. So let me write the problem for you. This is x to the 3rd power minus 20x minus 5 divided by, it's kind of short, that's not terrible, x plus 4. So what I want you to notice in this problem is that the power skips over the 2nd power, right? So we go from the 3rd power to the 1st power to the constant term, and we skip a squared power. That is not okay. So we need to write our problem. The one on the outside is fine. But what I'm going to do here is I'm going to put in a placeholder. And I use a 0x squared because that's nothing, right? That's really a 0. It doesn't change anything. I'm just going to stick that in there so I don't get lost. So if you're missing a power, you need to put a placeholder inside of there with a 0 on it. And now we'll just proceed as normally, right? So let's get started. There we go, there we go. X cubed divided by x is x squared. So that'll go here. So see, if my placeholder wasn't there, I'd be like, where does that go? Now we'll multiply x cubed, and then this will be plus 4x squared. And then also...
Miss Apple?
Yes, ma'am.
Miss Apple?
Yes, ma'am.
Hey, Miguel's checking out.
Okay, he's on his way.
All right, thank you.
You're welcome. Your assignment's on Classroom, Debbie, if you want to work on it. All right. So subtract, distribute negatives, negative 4x squared. Bring down the 20x, or the negative 20x, excuse me. And now let's do it again. Oh, I need a different color. X will go into negative 4x squared how many times? That's negative 4x. So that's exactly what I would expect. That lines up just fine. This will be negative 4x squared minus 16x. Subtract, distribute negative, negative 4x. Now bring this dude down, minus 5. Have a good day, baby. All right, last bit of division. We're going to divide these two things. So here's my work. Negative 4x divided by x is just negative 4. This will be minus 4. So now we're ready to multiply again. Why did I do that? I don't even. I got distracted. All right. So where was I? We're multiplying. Okay. Negative 4 times x is just negative 4x. Negative 4 times positive 4 is minus 16. Subtract. Distribute negative. What's that, 11?
Yeah.
Okay. X does not go into 11, and we're out of room. So this is my remainder. 11 divided by x plus 4, and we're done. All right, I'm going to do one more long division example, and it's going to have a missing power on the outside this time. There we go. With this one's number 6. So this one's over again. 10x to the 4th minus 12x to the 3rd plus 29x squared minus 24x plus 9 divided by x squared plus 2. So let's check both polynomials, right? I got standard form in the first one, 4, 3, 2, 1, 0. Yeah, powers 4, 3, 2, 1, no power. This one, however, has a hole in it, right? It doesn't have that linear term or the term with the x to the first. So now I need a placeholder there. So I'm going to say plus 0x plus 2. Then I'm just going to proceed just like normal. And everything else is going to happen exactly the same as it has been happening. It's just important to make sure that, and I say that emphatically to you because having to start one of these over because you forgot to put a placeholder in after you use a half a sheet of paper is infuriating. Okay? Like you do the whole thing, you're like, why? And it doesn't matter how many of these things or what's out here first. We do the same thing. The first into the first, right? The first thing into the first thing, and we don't care about the rest until we start multiplying. So this would be 10x to the 4th. How many times will that go? Well, 10x squared. Right? So where do the squareds go? Above the other squareds. So I'm going to just skip both of these. It seems crazy, but that's what we're doing. And now we multiply, just like we did before. So this would be 10x squared times x squared. That's going to be 10x to the 4th. 10x squared times 0 is just 0. 10x squared times 2 will be plus 20x squared. So see how with that placeholder, everything lines up according to plan. And without it, stuff starts getting messy. And when we're doing something like this, we definitely do not want messy. Okay. So this drops out as expected. Negative 12x to the 3rd minus 0 is still that. This is plus 9x squared. I haven't brought anything down yet, so that's got to happen still. So now I just have 3 things to deal with. Okay. But that's okay. This is not a problem because we are still just going to look at the first one and the other first one. So here's my work. You can see it without doing this, then, knock yourself out. There we go. I have to do it over there. It's just too much for my brain to do it once. So it's minus 12x. And now we're going to multiply. So it'll be negative 12x to the 3rd plus 0, because 0 times anything is 0. Negative 12x times 2 will be negative 24x. Okay. We're ready to subtract now. Okay, so let's subtract again. Subtract this, apply the negative, distribute that. Okay, so now 9x squared, that goes away. This is 0x, right? Or you just put a 0, whatever. But just to keep you straight, you need it there. We're going to drop all those zeros at the very end, not until then, okay? Because otherwise it's going to mess us up. Got 3 things again. We don't care. We're going to do the same thing we've been doing. We're going to look at this first thing and this first thing, and that's all at first. Divided by x squared, that's just going to give me 9, right? So that's plus 9. Then you're gonna multiply it again, 9x squared plus 0 plus 18. And now we're gonna subtract again, just like we did before. We're gonna distribute our negative. That's nothing, this is negative 9. Does x squared go into negative 9 at all? No. So that's my remainder. So I'm going to come up here and write it just like I did before. Except this time it's minus 9, because that's a negative 9. X squared plus 2. That's it.
So in the answer, would we get it wrong if we put x squared plus 0x plus 2?
I would prefer, I'm not going to take all your credit for something like that, but I do want all of the understood zeros and ones gone.
Gone.
Yes, please. In the final answer. So like, even if in this stage you have it, when you box your answer up, like this is it, it's cleaned up, it's done. I do want all of those understood numbers gone. Okay. So zeros that don't do anything, ones that don't do anything, powers that don't do anything, etc. Okay. I'm going to, so that's long division. I'm going to show you 2 more things today, okay? Let me show you, let's see. I'm not going to give this example a number. All right, so let's say I give you this problem, and it looks like this. 2x squared plus 12x plus 11 divided by x plus 5. So before, with long division, we've already done this problem today. If you noticed that, good job. So with long division, we're going to do it this way. And you don't have to write this down, just watch. With long division, we would do all of this, and we would set it up like this. It would be 2x squared plus 12x plus 11. Our lives would suck because this is a long problem. It's aggravating. So let me show you something else. You can write it down if you want, but I just want you to really watch right now. And then I'm going to explain what I did, okay? So that's going to be negative 10. Negative 10, that's going to be 1. And so then I'll just be like, okay, this is 2x plus 2 plus 1 over x plus 5. I'm done. And I got the same answer as I did when I did the long division. Yeah, this is called synthetic division, and it's awesome. So what I did here, and it only works under certain circumstances. I'll explain what those are. So if you have a problem like this, as long as the divisor is just an x, nothing in front, plus a number. So no is like you can't do this, and you can't do this, or anything like that. But if it's just an x plus or minus a number, then we can use this trick, which is called synthetic division. And what I did here is, so notice I changed the sign of this. I put it right here. And I do an upside down fraction or a division sign. And I put all the coefficients here. So 2, 12, 11. I brought the 2 down, I didn't do anything to it. So then I said 2 times negative 5 is negative 10, and I put that right there. And I added 12 plus negative 10 is 2. And then I multiplied these 2 numbers again. Negative 5 times 2, negative 10. Now again, 11 plus negative 10 is 1. And then when you write your answer, you write it with these as the coefficients, but if you start at a power of 2 in your answer, you start at a power of 1. You go down though. I'm going to show you some more examples today. This is so much better. So really all I did was, I started with an x squared, so here I'll just put a regular old x. That's positive, so it's plus. That doesn't get anything, because I've already done that. And then this number is always your remainder. The last number, always the remainder. Let's see again. You like this there?
Yeah.
I think that's pretty neat.
Wait, so if the first one was x cubed, the first one right there would be x squared.
Yeah. Just go down by 1 degree. So if you start with a polynomial of degree 3, your answer will be a polynomial of degree 2. You start with a polynomial of degree 4. Your answer will be a polynomial of degree 3.
Did we learn this last year?
You may have seen it last year.
Yeah, last year did like a whole thing.
So you probably got through to that, because this is still algebra 2.
Oh,
Yeah, we're still in algebra 2. We're not in pre-cal yet. We're still finishing what we didn't get to last year. All right, so let's do another one. Let's do one like this. I like this so much better. All right, so let's say I give you a problem and it looks like this. We'll call this example 11. Say I'll give you 12x to the 5th power minus 4x to the 4th power minus 12x to the 3rd power plus 14x squared minus 22x plus 19. And then I want to divide all of that by, x minus 1. Okay, no big deal. So I'm going to swap my sign. I'll put a positive 1 out here. I'm going to draw my upside down box here. And then I'm just going to pull these coefficients. Notice their signs are coming with them. Pull all that down. And then this process is pretty quick usually. So 12 comes down, just bring it down there. 12 times 1 is 12. Negative 4 plus 12 is 8. 1 times 8 is 8. Negative 12 plus 8 is negative 4. 1 times negative 4, negative 4. So this will be 10. And this will be 10, and blah, 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 blah. Blah, 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 blah. That'll be 1 times negative 12, so that'll be 7. All right, now let's remember what I said. We have started here with a polynomial of degree 5. So when we're writing our answer, we're going to start with a polynomial of degree 4. So this will be 12x to the 4th plus 8x to the 3rd minus 4x squared plus 10x minus 12 plus 7 over x minus 1.
That's so much easier.
Yes, it's beautiful, right? But like I said, if you have a square here or something like that, it's not going to work. It only works when it's like this, but it does work super well and it's super easy. The only differences are really is that when you're vertically subtracting with the long division, you're vertically adding in the syntax. Okay? So this is addition where you're subtracting the long division. So yeah, this is super much better. And now I'm going to show you one last thing, but I'm going to ask you to do something before I do that. So, good. I'm just pausing for a second. It's hard to see everybody's heads and are really, really fast. All right. I'm going to go, and if we need to come back, we can. Or it's on one that I forget. All right, so I want you to do something. I want you to, I'm going to give you some instructions, and I'll have to explain what those exactly mean. Evaluate f of x at k. So I'm going to give you k, and I'm going to give you f of x. And I'm going to tell you what that means. So the function f of x, 2x to the 4th power plus x to the 3rd power. You're going to love this too. Soon, not at first. Not at first. Minus 3x squared minus 6x minus 1. Okay, and I want you to evaluate it where k equals negative 1. So all this means is, basically it means find f of k. And really what that means is find f of 1. So if you recall, that's just where you go plug in a negative 1 everywhere you see an x. So you just plug in. This just means plug in negative 1 for x everywhere. And then you should just get a number. Okay? So y'all do that. I'm not going to do that. I want y'all to do that. And then I'll show you a trick. Just remember, just plug it in. Make sure it's a negative number. So make sure when you're plugging in your calculator, you're putting that negative number in parentheses, or else it's not going to give you the number you want out of it. Just make sure you can plug that in and you can evaluate and plug it in. I'll give you all a couple of seconds to do that, and then let's make sure we all got the same thing. All right, so in essence, what I have done here, just to remind you, is I've said, 2 times something to the fourth plus something to the third minus 3 times something to the second minus 6 times something minus 1. And that something that I plug in for x is just -1 in all these cases. All right, so you should have had something like this in your calculator, and when you plugged it in, you should have just gotten, I think it's 3. Is that what y'all got?
Yeah.
Sweet. Okay, so let me show you a trick. I love days like this where like math is actually interesting. I think it's really cool. So just watch and then All right. So let's see. If I do synthetic again, it's going to be 2. That'll be -2. That'll be -1. That'll be +1. -2. 2. -4. That'll be +4, and that'll be 3. So the remainder is 3. If I just do kind of the synthetic division, so we can evaluate functions using the synthetic division method. The remainder is the value of the function at -1. I think that's pretty awesome. So anyway, what you do is, instead of changing the sign and I give you the number to plug in, you can plug it in if you want. You'll need to know that if I say, okay, what is the value of this function at -1? You can either plug it all in, or you can just do the synthetic division, and the remainder is the value of that function after you plug everything. You can do it like this, or you can do it like this and just take the remainder. The only difference is if you don't change the sign. Okay, so if you're dividing by some binomial, linear binomial, if I'm dividing by x plus 1, my synthetic division will have a -1 on the outside. And really, if you want to know, the reason for that is because if we solve this factor for 0, it will be -1. So it's -1. So in this case, notice I did not change the sign instead. So if we're dividing, for real, dividing the synthetic method, the sign will change. But if I'm asking you to evaluate a function at a particular value, the sign does not change. But the process itself is the same. You just have to know that the remainder is the value of your function. I don't care about this. Okay, that's wild. I don't know if y'all think that's really cool, but I think it's really cool because this doesn't even seem related to this in any way. But it works every single time. It's even got its own name. It's called the remainder. Yeah, so that's all for today. Your assignment is in classroom. Got the rest of the block to work on. The first, number 1, can be solved with synthetic, but your instructions say to do it with long division. So don't do it with synthetic. Okay, that's it. Let me help you. I have a key. I'll be happy to let you check answers as you go. Woohoo! It is a procedure day. We love those.